We shall see. Feels like no, you should just do it.
What?
Feels like you should do it.
Well, yeah, it's too much work to put in.
Give you one more minute, and we'll roll you rolling. Have run away to school.
You've heard that? On the way to school?
Yes, I have children who hate terrible, who like terrible musicals.
What's 2 plus 7? What's 2 times 17?
Are we ready? Yes. Okay, so here we go. When you, this has been a recent trend on the AP test. It used to be more traditional, and these are more thinking outside the box problems. So I want you to get a good amount of practice. Unfortunately, our book doesn't have it, so that's why I'm going to have to replace it. The idea being that if you want to estimate the true volume of this, but with only limited data to go on, then when you take a first right rectangle of that, and you say the delta x or delta h is 2, in the cross-sectional area, do you use the cross-sectional area at 0 or at level 2? 2 is 17, and you get 34. Helps to visually understand what the heck you just did. You just said, pretend like the area was always 17 for that level, and therefore the volume of that green cylinder would be area base times height. It would be, when I say 34, it really would be like the volume there. Now, I'll show you, it seems like we're overestimating, and it's probably the case, without knowing for sure. What it looks like. You with me? All right, so the next one then is a delta H of, going from 2 to 5, so 3, and we use the right edge, which is at a cross-sectional area of 16, so the volume there is 48, and again, that would be like if we took this as if this was always the case for that region, and sum that, okay? What about the next delta H? 2 and times the cross-sectional area of 9. Why do the units seem to make sense here for volume? What are the units on cross-sectional area? Units squared. And what's the height each time, or delta H? Units. Well, units squared times units give me volume each time? Yeah. So that's 18. What's the next delta H? 2, isn't it? 2 and then 6 for the cross-sectional area. And the next delta H is 5, and the cross-sectional area we'll use is at the right-hand side. So 7, right? So that's 35. So did you get an estimate? And it is an estimate of the volume, not exact. What do we got there? 82, 100, 112, 147? 147 cubic units. You with me? Okay, cool. The lesson, yay, slope fields. This is kind of cool. Did you ever do dot to dots when you were a kid?
Nope.
You didn't do dot to dots in, like, you didn't have, like, coloring books? Huh? Yeah, connect the dots. Sorry, we call them dots. Connect the dots. That's old people call them dot to dots. Connect the dots. Yeah, this is like that, except a little more complicated, but not much. So it goes like this. It's like if you did dot to dots with calculus. Okay. Okay, boom. Okie dokie. So check this out. This is a differential equation lesson. It's a way of visualizing what the graph would look like without even integrating, just by going by what the derivative says. So imagine if I asked you to find the general solution to dy dx equals 2x. What does that mean when you are given a differential equation and you're asked to find the solution? Find the original yx equation. And we do that first and foremost by separating the variables, because in AP grading, if you don't, you're in big trouble. So if you do that, then integrate both sides. Whatever you do to one side, you do to the other. You get y equals x squared plus c. That is the general solution. It's a family of solutions, all of which have the same shape. It could be x squared plus a 0 y-intercept. It could be x squared plus a 2 y-intercept. It could be x squared minus a 3 y-intercept. 1, 2, 3, 1, 1, 2, 3, 4, 5, 1. Okay. We get lots of possible solutions. Lots and lots of solutions. I could keep going, obviously. Now, if I asked you for the particular solution, then that means they're giving you a little more to go on. Yeah, it has a derivative of 2x, but it also originally went through the initial condition 2, -1. Well, if you start with the point 2, -1, and then say, all right, then what about the graph there? Well, I could use 2, -1n to nail down the c. -1 equals 2 squared plus c. The c, in that case, would have to be -5, and the equation that has a derivative of 2x, but also passes through 2, -1, is y equals x squared minus 5. If I were to graph that, it would look something like this, if I drew it nice and heavy. Actually, I'll just draw it for you to, and what do you think? Give it a little smiley. Okay. All right, so at any rate, that's the particular solution. Are you with me so far? Great. Thanks for that. All right, now then, if you eliminate this, okay, just calibrate my board. We were able to show a bunch of possible solutions there because we were able to integrate, right? You'll find, however, that not everything can be integrated. For example, if I gave you the differential equation dy dx equals 2x plus y, there is no amount of separating variables that gets y's and dy's on one side and x's and dx's on the other. It just can't be done. It's a non-separable differential equation. Now, that said, if you can't separate it, then it's doggone hard to integrate both sides. And so what's to be done? Well, the point of the day is, even when you get a derivative that can't be integrated, you can still graph the original function based on what the derivative tells you. That's what a slope field does. All right, so check this out. Imagine if the same dy dx equals 2x was used, and I couldn't integrate it. I could still get a little bit of points or slopes and make a slope field by saying, well, at different x's, what's the slope? Well, let's start with 0. At any x, the slope must be 2 times 0, or 0. Now, I don't know exactly what's going to happen, but I do know that that means anytime x is 0, the slope must be 0, just at that little instant. Now, technically, the minute you go off 0, it's going to start to be something besides 0. It won't be flat anymore. But wouldn't you agree that it'll be flat at the slightest instant? Yeah? So I'm going to draw little baby slopes there. And this will be a field of slopes. Now, if I were to then go to another possibility, when x is 1, now I'm jumping straight to 1 just because it's clean, but I could do a slope at a half. There are slopes at a half too. It's just ugly, so we're going to jump to 1. What is the slope of any possible equation of 1? It must be 2. Now, if I go to draw all the possible slopes at x equal 1, when you go to draw a slope here, I'm going to obviously be there. This is the hardest part for students. How do I draw? Well, imagine a point that's up 2 over 1 away. So when I put my point here, I'm trying to just point in this direction. So I'm going to do a little slope pointing in that direction. And this guy, when I did a slope here, up 2 over 1 there would be to point to this point. Now all these should be the same. So once you make one, you could usually just try and make all of them parallel. You see where I'm coming from. Say we then went to x of 2. What's the slope at any point where x equals 2? 4. The slope's got to be 4. So if I start here and try and do a slope, it's up 1, 2, 3, 4 over 1. I'm going to try and point in that direction. So that surely should look steeper than the ones next to it. Draw one and then try and stay parallel. As far as how you grade these or look at these, it's just relative to each x, are they getting steeper? So at x equal 3, for example, the slope is 6, and so it should be very steep, almost vertical. And then on the left-hand side, what's the slope at every negative one? Negative 2. So put your point there. Imagine a point that's down 2 over 1 away. So if I pointed here, here, 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1, like that. And then at negative 2, the slope is negative 3, negative 3, negative 4, negative 4. So if I go here, that's down 4 over 1, that's pretty steep. There should be some symmetry there to the left side of the graph. And negative 6. Very steep, very steep, very steep, very steep, very steep. All right, now that's a slope field. Looks pretty intimidating and fancy, but it's not that big a deal. It's just a lot of little calculations, yeah? Now, when you go to do this quickly, you try and save yourself some time, because if you don't look for trends, then you're going to be making something like you're going to be looking at something like 64 different calculations if you don't look for trends. So you want to save yourself some time. In this case, every x is the same. You can see then that when the slope depends only on x, then that means once you get one done, you can just copy up and down. But if the slope depended on x and y, it would probably vary horizontally and vertically, and then you got to make lots of calculations, all right? Now, just like before, we could get an exact solution through a given point. If I gave you if I gave you a point that it went through, then you could do a little dot to dot, connect the dots kind of thing. I'm telling you that there was an original curve that went through to negative 1. So right here, yeah? Now, our goal is to try and follow the slopes where they take us. So going to the right, isn't this slope?
That's 1, negative 1.
Oh, yeah, sorry. I'm not thinking. 2, negative 1. No wonder you're confused. 2, negative 1 is here, yes?
Negative 2, 1.
Didn't we say, wasn't the previous, why did I change the points?
You didn't.
Yeah, the previous one is 2, negative 1. I thought I intended, whatever. All right, you're right. Negative 2, 1. Oh, no, I meant to use the same point. Negative 2, 1. Now, do we agree? Okay, sorry. All right, now then, going to where that takes us. Let's go to the left. What's the slope there? At -2, the slope was -4. So if I follow this way, wouldn't that slope be up 4/1? It would take me up, 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 yeah? Now let's go to the right. This slope is going to go down 4, right 1. And you could just go boom, 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 and go linearly. But the real deal of this is that the minute you go off -2, is the slope going to be -40? No, the minute you go off -2, the slope's going to be a little less steep. So I don't know if you should just go 1, 2, 3, 4, or over 1, but maybe more like head that way, but then start getting less and less steep. When you get to the x = -1 row, the slope is a little less steep, so maybe -2. When the slope gets to the axis, the slope goes flat, yeah? And then either using symmetry or just kind of using the same idea, the minute we go to the right side, the slopes start turning up. Now, they will never grade you for, oh, his is crossing at -3.5, and it's supposed to graph at -5. It's not that exact, okay? It's just, is it in the right kind of shape kind of thing? Are you following your slope? So don't worry if your x-intercept and your y-intercept is different than what I have. That's another issue. You with me? Okay. That said then, would you try the ones at the bottom? In terms of saving you time, would you write yourself a note, please, this? 0 over non-zero is 0, obviously. 0 in the bottom, so that's horizontal slope. If you see a 0 in the bottom, that's actually a vertical slope. Undefined, yes, but you do draw a slope there, vertical. And if you get 0 over 0, you should graph nothing because there is nothing to do there. Okay? So go ahead. Somebody remind me to talk about the schedule this week. Feel free to peek over at your buddies and say, do ours look the same? That's good. Saturday, release episode. I made a table in the previous one, but you definitely don't have to do that. You can just do these mentally. If the table works for you, then do that. That's fine. But I don't grade for or require the table. Probably need to make your slopes a little heavier when you're on the axis so they stick up. agree with the first one? In terms of looking for trends, where will the second one have a zero slope? Zero slope when what happens? When y is 2. So when y is 2, 0, 0, 0, 0, 0, 0. When y is more than 2, what kind of slopes do I have? 2 minus more than 2 is negative. I'll have negative slopes above that, positive slopes below that. Okay? These are the kind of trends you look for to save yourself time. And they're always going to be, in this case, they're going to be the same for every x, but different for every different y. So these are one slopes. 2 minus 0 is 2 slopes. Oops. Two minus negative 1 is 3. Very low. And they're just going to get steeper and steeper as you go down. All right. How are we doing in the second one? Okay, very cool. What does it look like is going on with the graph in the second one? The original graph looks like it has a horizontal asymptote at y equals 2, and that's true. We can talk about the antiderivatives here. What would this curve look like? What's the antiderivative? Natural log plus c, so it could be natural log plus nothing in here. It could be natural log plus 1. It could look in here, but it makes sense that it's that shape because natural log plus absolute value would allow for negatives and such. So yeah, that makes sense. You don't have to integrate, but if you can, and you know that makes sense, that works too. The last one's the hardest because it varies both horizontally and vertically. Let's start by saving you some time. This is vertical slopes if what? Y equals 0, okay? With the exception at the origin, you put nothing at the origin. So there's vertical, that's x equals 0, dummy. Vertical slopes where y equals 0. Here, yeah? That's horizontal. What the freaking heck is this? Vertical slopes where y is 0. I can do those two things together, no problem. All right. What about horizontal slopes? Horizontal slope if x equals 0. If x equals 0, then you're at the y-axis, and so that's horizontal. Boom, 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 boom. Okay? Tell me about signs. In the first quadrant, what will the slopes be, positive or negative? Positive, because x and y are positive, they'll have positive slopes. In the second quadrant, the slopes are negative. In the third quadrant, the slopes are positive, because negative divided by negative will be positive, and negative. These are kind of the thought processes when you do matching in multiple choice, which we'll do next. Okay? All right. So then, at 1, 1, the slope is 1. I'm just going to do some calculations. At 2, 1, the slope is 2 and 3. It feels like they're getting steeper as x gets bigger and bigger. That makes sense. X is in the numerator. Now, as far as where I'm going to go next, I'm going to now follow that same kind of thought process over here, except instead of positive 1, this will be negative 1, negative 2, negative 3. Then I'm going to go down to the lower quadrant, positive 1, positive 2, positive 3, and in the fourth quadrant, negative 1, negative 2, negative 3. Now I'm going to build up to the second row when y equals 2. At this point here, it's the point 1, 2. So the slope is 1/2. So flatter slope. But as I go here, 2, 2 is 1. And 3, 1 is, or sorry, 3, 2 is 3 1/2. Yeah? Ish. So it looks like they're getting steeper as you go this way, flat, more steep, more steep, flat, more steep, flat, more steep, and more steep. And you get the idea. That's good. You with me? All right, let's try the other way. There's two different types. So it's pretty common on a free response. You're asked to make a slope. It's easy to do. It's usually 2 points. It's not too bad. Okay. Second thing then is it's very common on multiple choice. You'll do one of two different types of problem. You'll either try and match a slope field to a differential equation or a slope field to an original solution equation, right? So that's what we have on the back here. These, would you write down, these are your, how you do this matching kind of thing. These are the strategies that I employ, and that'll save you some time as far as eliminating choices here. First, find where there are zero slopes, no slopes, vertical slopes kind of thing. Let me explain how I could use that, and then we'll go on here. So, for example, in differential equation 1, that's what DE1 stands for. Differential equation 1, this would equal 0 anywhere y equals x. Anywhere x and y are the same, that would 0 out. So look through there and look where along the line y equals x. And where do you see slopes equaling 0 along y equals x? Well, here's one. Do you see along y equals x, 0, 0, 1, 1, 2, 2? All those slopes are 0. So that's a possibility. Okay? That might be it. That, not that, not that, not that. Not that. This here also feels like along y equals x. Those are 0 slopes. So that's a candidate, and really that's all. So I've already, with that thought process, narrowed it down to slope field 2 or 3 or 8. You with me so far? Okay. After that, you could, I didn't do this well. You could do quadrant signs. Now I typically do quadrant signs. Well, let's just talk signs. When is that going to be positive? I know it's 0 at y equals x. It would be positive anytime x is greater, and anytime it would be smaller anytime y is greater, all right? So it would probably be positive if x is greater than y, and negative if x is less than y. So with that in mind, does that help us any? Here, when x is greater than y, like here at 1, 0, that's a positive slope. But it feels like this would give me, oh yeah, that's a positive slope also, yeah? So that feels like that's got a chance. What about this guy at 1, 0, for example? That slope looks like it's negative, but I know at 1, 0 that's positive, and so I could say that's not it because it has the wrong signs on either side of those zeros. You with me? Okay. Also, use horizontally or vertically. For example, if the slope does not change horizontally, then x doesn't matter. The differential equation, it only has y's in it. So look at slope field 2, for example. Wouldn't you agree that as I go side to side, all those slopes stay exactly the same? That means to me that x does nothing to the slopes. The slopes do change vertically, which means the slopes depend on or relate to y. So for this one, I would look for a differential equation that has y only in it. So maybe this one or this one. That also would go through my head, and then I could use a point, or this one, and I could use a point like that. That's all. I wanted to get you a start. You could use points. It's kind of the most slow method to just try a point. That's like the last case to help you decide between two. So you don't want to do that. And also, if you know the antiderivative, that's also super helpful. For example, if dy dx is x, then what's the antiderivative? X squared. You're looking for a slope field that has to do with x squared. So you might say, oh, well, shoot, that one's obviously Which one? Slope field 1. Okay. So those are the thought processes. Could you try those? Check them over with your math amigo and we'll confirm it. Zero slopes, quadrant signs, know the antiderivative, try a point, vertical slopes. Ready? Yes. Hey, differential. Excuse me. Sorry. Differential equation 1. What do you say? Did we already do that? Oh, what was it? 8 or 4? 3? Top 3. Okay. What about differential equation 2? 6? Do we all agree? Yes? No? Okay. Differential equation 3. Is that 8? Yeah? Okay. Differential equation 4. What do you say? It's flat at x equals 0. It's probably, I'm feeling it's negative, positive, negative, positive as far as signs. So what do you say? 7? I agree. That seems reasonable, at least. Hard to see the slopes to 0. Okay. What about, we did that one, that was slope field 1. Is that correct? What about differential equation 6? What? Anybody? So it's between, it's this or which one is like it? There isn't one that's like it. So it's horizontal and vertical at x equals 0. So it's hard to see that. They're on top of the things. Maybe I'm thinking wrongly. that's 7. That's 7's already used, yeah? What? This one should be 5. So let's think about that. Wouldn't you agree that as y gets smaller and smaller, the slopes would get steeper and steeper? So it should be steeper this way and flatter this way. So the signs say these should have the same sign pattern. But as far as which one will get steeper, this gets steeper horizontally like that, okay? So I agree. This one is getting steeper horizontally because as x gets bigger, the slope would get steeper. It feels like this should be 5, and 7 would be more like as y gets bigger, the slopes get steeper. So this is 7, this is 5. Okay? Differential equation 7 is flat at y equals 2. Which one is flat, or sorry, at y equals 0? And then as y gets bigger, which one is that? What'd you say there? 2? No, I feel like it should be flat at 0. So 4 and greater, as y gets bigger, it gets steeper. So I'm feeling 4 is a good candidate, and that's it. Is differential equation 7 4 then? Is what I get? Yeah? This guy had 0 slopes when y is 0 and 4. That has 0 slopes at 0 and 4, so this is 10. That's logistic. And last but not least, the last row, when y is 2, it goes flat, so that's slope field 2. And x plus y is 0 along y equals negative x. Where do you see 0 slopes around y equals negative x is right there. That's done. Yeah? We agree. All right, last skill then. Which of those equations or differential equations, or sorry, which slope field matches these original equations, not the derivative? Which one matches this original equation? What does this graph look like? It's a circle. Which of those slope fields, if you did a little connect the dot, could look like a circle? It is 5. Okay, so you'd go with, if, for example, you had an initial point, you would say that. So that's differential or slope field 5. What about x squared minus y squared equals 9? At the hyperbola opening horizontally, which slope field would make that kind of graph? Could be this guy, or it feels like not that guy. It feels like this guy, yeah? So it is slope field 6. What about y equals negative e to the x? What does that graph look like? It's e reflected how? Across the y-axis or across the x-axis? Across the x-axis. So which of those graphs looks like it could be that? No, no, no. That could be it, yeah? 4 and seems like 4, yeah? And what about 3 plus e to the negative x? That would be shifted up 3, and what does e to the negative x do? Across the y-axis, so I'm feeling something like that. Which of those graphs could match that kind of behavior? 2, yeah. 2. Okay? That's the idea here. That's what you're looking at. Okay, questions on set 98. 98 questions. Said, oh, I have to back today. Here are, let's see, you got your extra practice 37, 97, and some practice tests. So, Three things coming at you. All right. Any questions on 98? Three?
9 and 20.
3, 9, and 23.
No,
Not 9.
not 3.
Not 3.
9 and 20.
Are you sure? Are you sure nobody said 3?
Oh, okay.
I could have sworn. Somebody said 3. Are these replaced in any way or straight up out of the book?
9 is
9 is replaced. Okie dokie.
20 and 25.
20 and 25. Make sure we have the same thing here.
Good morning, Dublin Jaguars. Please rise for the Pledge of Allegiance. Ready? Begin. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
Okay. Yes. What? Oh, yeah. This is due Friday. I just wanted you to have plenty to work on with the long study solve. So this is
This Friday and Saturday,
Said 90, what up for is your first homework you should be working on?
Mr. White,
It's due
and
Wednesday.
Mr. Northway make their Dublin stage debut at the Wicked,
What?
the Wicked Witch, Dr. Doolittle, and Toto. $5 tickets for the Enchanted Book Club will be on sale at the door on the Dublin Auditorium at 6:15 for the 6:30 show time.
It's. You have a first period on Wednesday and then a couple stuff on study also. All right, 9.
Senior high student scholars of the month. Ryan Yost has demonstrated a great thirst for knowledge. He engages daily in discussions and asks excellent questions and makes insightful observations. He has worked hard to improve his personal approach to learning and assessment and has made great strides on improvement. He has shown how he values academic integrity and respecting the learning environment, and is ready and willing to try new things and take on new perspectives, showing that he is committed to lifelong scholarship. Ryan was nominated by Mr. Powers.
Great building is passionate about learning and seeks out understanding and wisdom fervently. If she doesn't understand something initially, she will work tirelessly to understand it and will not give up seeking out the truth. She does excellent work and asks excellent questions. She treats others with respect and is always considerate and supportive of the structure of learning practice. She is an excellent example of a Dublin scholar. Ren was nominated by Mr. Powers.
Finals care packages. Don't miss out. Make sure a finals care package has been ordered for you. They can still be ordered until Friday, April 19th. Purchase on the Jesco Fees website or at the financial office. It costs $15 for the spring semester. Don't miss out on this fun tradition and important school fundraiser.
All 8th through 11th grade boys and girls. Cheers trial packets are available now at the fellow office. Pick up yours today and be part of the competitive sport. Get the opportunity to cheer on your fellow Jack and travel to Disney World.
Testing information. 7th and 12th grade students, you will not have school on Tuesday, April 9th. The other grades will be testing that day, but you will stay home. 8th, 9th, 10th, and 11th grade students, you will be having state testing tomorrow, Tuesday, which means you need to be here at school at 7:30 a.m., but your day will be done after testing at 12:20. Leave your cell phones at home or keep them in your car. If you are found with a phone during any time of the testing, your phone will be taken and your test will not be recorded. The buses will pick up as usual, but will take you home at 12:20. Lunch will not be served on this day. This week we will start a new math testing schedule. Please look at the posters that will be posted in the hallway.
23.
8th through 11th graders, please come pick up your information package.
You need to remember your identities.
Learn how to navigate your attending are eligible to a free private 1-hour consultation.
Okay, So it's 1/2 minus 1/2 cosine of double the angle. Well, if the angle was 2x, now it's
Our 5-1 soccer team is meeting 5A Lakewood Friday, evening at 5:0 at Lakewood Memorial Field.
with me.
Lawrence Cook had 1, Thursday had 1 at 2, and Autumn Hopland had 2 goals for the Jags. Kira has 7 goals and saves. Next up are
7 goals and saves. Okay, and then a little use of the action, or mental use of if you can. Okay, get this to me by the end of the day. I could try, but I promise you. Otherwise, just let me know. Peace, people, peace. Thank you. Have a wonderful day. Hope something great happens to you.
You too.
Thanks. Sure will.
I'll take it.
Yeah. Why did you fail?